today's class. So in today's class, we are going to be looking at circle geometry. So the topic says circle geometry. As we know, under circle geometry, we must have learned about properties of a circle, that is part of a circle. So just such as center of a circle, circumference of a circle, radius, chord, and so on like that. Then that will lead us to the theorems under circle geometry. And we are starting with the first theorem. Before we go to the first theorem, we define theorem as a mathematical rule or proposition that can be gotten by solving or multiplying or by proving the formulas of reasoning. So here now we have theorem 1, and theorem 1 states that a straight line drawn from the center of a circle. So that's why I said we must have learned about the properties of a circle. So we have a straight line drawn from the center of a circle to the middle point of a chord, which is not a diameter, it's a right angle to the chord. So all what we are saying here is, they are the properties of a circle, or they are the part of a circle. We have the center, we have the middle point of a chord, so we have a chord there, we have a right angle and so on, and we have a diameter. So we must have learned about property or part of a circle. So let me interpret this theorem. The theorem says a straight line drawn from the center of a circle. A straight line drawn from the center of a circle. So we have a circle like this. Then we have a straight line. The center of the circle is given as center 0. So a straight line drawn from the center of a circle to the middle point of a chord. So the chord is defined as a line that runs from one part of the circumference to another part of the circumference, not necessarily pass through the center. So we have a chord like this. So we have chord. This is the chord that is called AB. So the line AB is given as chord. So we now have a line, a straight line drawn from the center of a circle. So here is the center of the circle, and we have a straight line drawn from the center of the circle to the middle point of the chord. So let's assume this is the chord, then the middle point of the chord is somewhere. You now draw a line from the center to the middle point of the chord. So let's call this point D. That's the middle point of a chord, which is not a diameter. That is, the chord given is not a diameter. If we are to be diameter, it means the line will pass through the center. But the line doesn't pass through the center, so it's a chord. It's at right angle to the chord. So it's at right angle to the chord. It means the angle between the line drawn from the center and the chord given is right angle. So this is the symbol for right angle, which is angle 90. So we have angle 90 here. So you can bisect this. You join point O, that is the center of the circle, to point A. So we have this, which is what? Radius. Then we have another from here up to this place is also radius. So as to have a complete triangle. So we have this interpretation now. So the theorem says the angle between the line drawn from the center of the circle and the chord is at right angle to the chord. So it's at right angle to the chord. So that's just the summary of the theorem. So invariably, it will now be, therefore, angle ADO. We can have an angle like this for ADO. ADO, that is ADO. This angle and angle BDO, they are equal. Angle BDO, which is equal to what? Right angle. Right angle is angle 90 degrees. So invariably, angle ADO equals to angle BDO. So that is the line drawn from the center to the middle point of the chord, which is not the diameter, is at right angle to the chord. That is the angle between the line and the chord is 90 degrees. That's just the summary. So that is that on the first theorem. So let me give you the example under theorem 1. So example on theorem 1. So example 1 under theorem 1. So the question says PQ is a chord of a circle. So if you are to interpret this question, you must have a circle and you must draw a line PQ, which is a curve. So solution. So the first thing to do is to draw the circle, then locate the center of the circle, then draw your curve. So you name the curve PQ. Then this is the center of the circle. Then PQ is a chord of a circle. The radius of the circle is 10 centimeters. So the radius that is from the center of the circle to point P is a radius. Then from the center, which is point O, to point Q is also radius. So we now have 10 centimeters for the radius. Along OQ, then OP is also radius, which is also 10 centimeters. Then, and the distance of the main point of the chord. So let's assume this is the main point of the chord. The distance of the main point of the chord from the center of the circle O, from O to the main point of the chord. So let's call this A. So it's what? It's given as 6 centimeters. 6 centimeters. So the question now says, calculate the length of the chord PQ. But according to Theorem 1 says a straight line drawn from the center of the chord, from the center of the circle to the middle point of the chord, which is not a diameter, is at right angle to the chord. It means we have a straight line from the center to the middle point of the chord. Then the angle between the straight line and the chord is 90 degrees, which means triangle QAO or OQA or OAQ is right angle triangle. And if that one is right angle, triangle OAP or OPA is also right angle triangle. Because we have angle on the straight line. If this side is 90, this side will also be 90 degrees. So to now get length of the chord, we cannot just get the total length of the chord like this using Theorem 1. You just need to get half of the chord, then the second half of the chord. So according to this Theorem 1, it means line PA equals to line AQ. So this PA equals to AQ. So whatever you get for AQ is what you are going to get for PA or AP. But the length of the chord, question A, the length of the chord, so let me write here, the length of the chord PQ, let's say is given as, okay, PQ, that's what we are looking for, is unknown. The length of the chord is unknown. But the length of the chord PA is the same thing, PQ is the same thing as PA plus AQ. So once you know your PA, it will be equal to AQ. Then you write, let's say it is S plus S. It means PA is X and AQ is also X. So you can name this AQX and PA also X. So let's look for one of the S. Bring out this right angle triangle. So we have right angle triangle OAQ. So OQ is given as 10 centimeters. Then we have angle OAQ to be 90 degrees. Then OA is 6 centimeters. Then we are looking for X, which is AQ. So using Pythagoras theorem, because out of the three sides given, out of the three sides, we have two sides given to remain one. So by Pythagoras theorem, we are going to have hypotenuse squared, that is 10 squared, equals to 6 squared plus S squared. So we have 100, which is equal to 36 plus S squared. So therefore, S squared equals 100 minus 36. So X equals 64, that's S squared equals 64. Therefore, S is equal to square root of 64, which is 8 centimeters. So if S is 8 centimeters, you can now see PQ, which is the length of the chord we are looking for, equals to PA plus AQ. And PA and AQ are the same, which is S plus X. And one of the S is 8 centimeter, then PQ will now be 8 centimeter plus 8 centimeter, which is 16 centimeter. So the length of the chord given is 16 centimeter. So that is for question 1A. 1A. We are asked to calculate the angle called PQ sub 10 at the center. So this is called PQ. So called PQ form angle POQ at the center. Form this angle at the center, just like we did for PQ, that is AQ and PA. We are going to this line, the line from the center of the circle to the middle point of the curve, bisect the angle POA, which means angle POA is the same thing as angle QOA. So if you can just say let POA equals to theta. So we let POA to be theta, then POA equals to QOA. So if POA is theta, QOA will also be theta. So let's look for angle theta. So bring out the right angle triangle as well. So theta is given here. So this is O, this is A, and this is Q. So we have theta here, which is QOA. So theta. Let me put this right here. So theta, then line OQ is given as 10 centimeter, which is the radius. Angle A is 90 degrees. Then OA is 6 centimeter. Then to now get theta, we can make use of, we've gotten our AQ to be 8 centimeter. 8 centimeter. So you can make use of any of the ratio from the trigonometry ratio. So you can say by SOCAL. So you can say by SOCAL. So by SOCAL, you are free to use any ratio because all the sides are given already. So let's say by sine ratio. So sine theta equals, sine is opposite over hypotenuse. So to this theta now, opposite side is AQ, which is the opposite over hypotenuse. So sine theta will now be equal to opposite, that's 8 centimeter all over hypotenuse 10 centimeter. So centimeter because centimeter we have 8 over 10. So we now have sine theta to be equal to 0.8. Then theta will now be equal to sine inverse of 0.8. Then sine inverse of 0.8 is, so make sure your calculator is in degree. If you are solving problem under trigonometry ratio, so you press shift sine of 0.8. So the answer is 53.1301 degrees. But we are looking for the old angle, that is theta and theta. So you can now see, so this question B now. B. You can now see angle, the angle called PQ sub 10 is equals to angle POA plus angle QOA. So which is equals to angle theta plus theta. And what is the theta? 53.1301 plus 53.1301. So which is equal to, if we multiply this by 2, that is 106.2602. So approximately equal to 106.3 degrees. That is to 1 decimal place. So this is the answer to question number 1 under Theorem 1. So Theorem 2 says a straight line drawn from the center of the circle perpendicular to a chord bisect the chord. So let me interpret this theorem. The theorem says a straight line drawn from the center of a circle. So let's draw a circle. Then we have the center of the circle. A straight line drawn from the center of a circle perpendicular to the chord. So let's assume we have a chord there. So we call it chord PQ. And we have a straight line drawn from the center of the circle. Here's the center of the circle, perpendicular to the chord. So the line here now perpendicular to the chord. The meaning of perpendicular means is the angle between the line drawn and the chord is 90 degrees. So the angle between them is 90 degrees. So a straight line drawn from the center of the circle perpendicular to the chord bisect the chord. So it means this line that form as the 90 now bisect this chord. Divide the chord into two equal halves. So for us to have this, we are going to complete the triangle. So invariably, if the middle point of the chord is D, so this line divides the chord into two equal halves. You can now say therefore line PD equal to line DQ. Simply because the line drawn from the center of the circle divide the chord into two equal halves. It means if PD is 20, DQ will also be 20. So the total length PQ will now be 40. So that's just the simple explanation of theorem number 2. And the example is a chord. So example on theorem 2. And the question says a chord is 5 centimeters from the center of a circle. It means the distance from the center of the circle to the middle point of the chord is 5 centimeters. And that circle is of diameter 26 centimeters. So we are now asked to find the length of the chord. So the solution. So the first thing to do, you draw your circle. Draw a circle. Then after that, you locate the center of the circle. Then form your chord. So we have PQ. So it can be any letter. It can be AB. Then the diameter is given as what? The diameter is given as 26 centimeters. So just know that diameter is equal to 2 multiplied by radius. But we need radius to solve for what we are looking for. So diameter is given as 26 centimeters. So it's now going to be 2 multiplied by radius. So radius will now be equal to 26 over 2, which is 13 centimeters. So which means radius is half of diameter. Then the next thing to do is to form your triangle. Then the line drawn from the center to the chord is 5 centimeters. So just draw the line here to the chord. Then the distance between them is 5 centimeters. So we have to go by theorem 2. Theorem 2 says a straight line drawn from the center of the circle perpendicular to the chord. So far the line is from the center of the circle, then perpendicular to the chord bisect the chord. So here is the chord. Then we have this. Then the middle point, let's name middle point A. Then the radius. Radius is OP or OQ, which is 13 centimeters. Then we now have to find length of the chord. So to go by the second theorem, which is theorem 2, says the perpendicular line here, that is from the center, divide this line PA into 2 equal, that is bisect the chord. Divide the chord into 2 equal halves, which means if AQ is X, PA will also be X. Then draw one of the triangles out. So let me draw the left angle triangle here. We have this. So which is this? Then we have OPA. Then PA is X. Then PO is 13 centimeters and OA is 5 centimeters. So from here we get our X. So X will now be using solving by Pythagoras theorem is going to be PO squared equal to PA squared plus AO squared. What is PO? That's 13 squared equal to PA, that's S squared plus 5 squared. Then we have 13 squared, that's 169 equals to S squared plus 25. Then S squared equals 169 minus 25. So S squared equals 144. So S will now be square root of 144. S is equal to 12 centimeters. So if if half of PQ is 12 centimeters, then total PQ will now be what? That is 12 times 2. So the length of the cord, PQ equals to PA plus AQ. PA and AQ are the same. So if PA, which is S centimeter, is equal to AQ, which is also S centimeter, it will now be 12 centimeter plus 12 centimeter. So the answer is 24 centimeter. That is the length of the cord PQ. So that is the example under the second theorem. So we now move to the third theorem. So theorem number 3. So theorem 3 says equal chords of a circle are equidistant from the center of a circle. So equal chords of a circle. So let's have our circle. So the theorem says equal chords of a circle are equidistant from center of a circle. So let's assume we have this chord. So we call this chord PQ. And we have another chord opposite to each other. So let's call chord AB. So we call the second chord AB. So the theorem now says equal chords of a circle are equidistant from the center of a circle. So from the center of a circle now, here is the center of the circle. So if you take this to the middle point of the first chord of the chord AB, and this one to the middle chord of chord PQ. So here is the center of the circle. So what this theorem is telling us is if PQ, that is line PQ, equals to line AB, then, so let's call this D and C. Then DO or OD equals to OC or CO. So this is the summary of this theorem. So the theorem says equal chords of a circle are equal distance. So equidistant means equal distance. That is from the center of the circle. So if we are given chord PQ and chord AB of the same length, so if they have the same length, it means the distance from chord PQ from the center will be equal to the distance of chord AB from the center, that is OC will be equal to OD. But let's now assume we have two chords, but they are different dimensions, different length. It means distance OD will not be equal to distance OC. That's just the summary of the theorem. So for us to have equal distance from the center, chord AB must equal to chord PQ. So that's just the simple explanation on theorem 3. So let's now go to example under theorem 3. So example on theorem 3. So example on theorem 3. So don't forget theorem 3. Theorem 3 says equal chords of a circle are equidistant from the center of a circle. So we have this, that is if the chord PQ is the same thing as chord AB, then the distance from O, that is the distance from the center of the circle to chord PQ, will be equal to the distance of the circle distance of the center of the circle to chord AB. So now you have to sum that is if PQ equals to AB, then DO or OD equal to OC or CO. So example says this diagram shows two parallel chords. So we can draw the diagram ourselves. We're given the diagram in the question, but we can interpret by drawing the diagram from the question. So this diagram shows two parallel chords, AB and CD. So let's draw the diagram. So we have a circle of, here's the center of the circle. So let's say we have chord AB and CD, chord CD lie on opposite sides of the center. So these are the opposite sides of the center. So we have this down. Then of the circle, AB is 40 centimeters. So length of AB is 40 centimeters, and length CD is 30 centimeters. That is from C to D, 30 centimeters, length of the chord. And the radius of the chord is 25 centimeters. I mean, radius of the circle is 25 centimeters. So here, you can just draw your radius like this. So to connect the center to the chord, to the two chords. Connect the center to the two chords. So here's the center. So radius is 25 centimeters. That is chord AB. Then you can join it to chord CD as well. That is radius is also 25 centimeters. So calculate the distance H between the two chords. So to have the distance between the two chords, just draw this. So here, then here. So this is the distance H between the two chords. So to know that, we are going to make use of the first, second, and the third theorem here. So the first theorem says a straight line drawn from the center of the chord to, the center of the circle to the middle point of the chord, which is not the diameter, bisect the chord. So we have the bisection of the chord, which means this place will be 20 centimeters and this place will be 20 centimeters. Then the second theorem says a straight line drawn from the center of the circle perpendicular to the chord bisect the chord. So this bisect the chord, and we have a straight line drawn from the center of the circle to the middle point of the chord, which is not the diameter, is at right angle to the chord. So this is at right angle to the chord. That's the first theorem. Then the second theorem is a straight line drawn from the center of the circle to the middle point of the chord bisect the chord. So we have 20 centimeters. That is, let's call the middle point of chord AB. Let's call it E. Let's call this place E. So we call this place E. That's the length here. Then the total length of the chord AB is 40. Then the same thing goes for chord CD and the center of the circle. Then we have 15 centimeters here, then 15 centimeters here. Because this line from the center of the circle perpendicular to the chord and also bisect the chord. So we have this now. So we are looking for H, let's say small a and small b. So let's look for small a from the triangle OBE. So you can now say from OBE, that is triangle OBE, right angle triangle OBE. So we have this triangle, this right angle triangle. So this is E. So we have O here, we have B here. So the length BE is 20. Then the angle here is right angle. Then radius is 25 centimeters. Then small a is small a, we don't know it. So by Pythagoras theorem, we now have hypotenuse squared. Hypotenuse squared is 25 squared equal to adjacent squared, that's small a squared plus 20 squared. So we now have 25 squared. 25 squared is 625. 25 squared, that's 625, equals to a squared plus 400. So we now have a squared equals 625 minus 400. So a squared equals 225. So a equals square root of 225, which is equals to 15 centimeters. So minus 400, the square root of this, that's 15 centimeters. So small a is 15 centimeters. That is the distance of the center of the circle from the middle point of the chord AB is 15 centimeters. So let's look for the distance small b. So consider the triangle. So from triangle ODF. So let's call this middle point of CDF. So from ODF, so draw the triangle out. So this is F, this is O, then small b, then we have 15 centimeter D, then radius which is 25 centimeter. So we are going to make use of Pythagoras theorem as well, which is 25 squared equals to b squared plus 15 squared. So we have 25 squared, that is 625 equals to b squared plus 15 squared, that is 225. So we now have b squared equals 625 minus 225. So b squared equals 400. So if b squared is 400, b will now be square root of 400, which is equal to 20 centimeters. So small b is 20 centimeters. So the question now is calculate the distance between, distance h between the two chords. So distance between the two chords will now be from there up to this place. That is small h, which is the distance, equals small a plus small b. Small a plus small b equals what? Small a is 15 centimeters plus small b 20 centimeters. So the answer is 35 centimeters. So if you have to go by Theorem 3, Theorem 3 says equal chord of a circle are equidistant from the center of the circle. Assuming line AB is 40 centimeters and line CD is also 40 centimeters. It means if our A is 15 centimeters, small a is 15 centimeters, then small b will also be 15 centimeters. Why we have different in small a and small b is because the two chords given, they are not of the same length. And they mean they are of the same length. We are going to get equal distance from center, that is small a will be equal to small b. But since we have different length in the chord, we are going to have different dimension in the distance from the two chords from the center of the circle. So that is that on theorem number 3. Thank you.